Hi class. Today we're going to continue on with chapter 3. We're going to talk of slopes of lines. So our objectives today are to find slopes of lines and to use slope to identify parallel and perpendicular lines. And I promise today's notes are going to be a lot shorter than yesterday's. All right, let's start off by looking at this problem. Ski resorts rate their trails by difficulty level. A primary factor in rating the hill is the slope of the hill. Generally, easier trails have a slope that ranges from 6% to 25%, where the more difficult trails have a slope of 40% or greater. So if we take a look at our picture on the right side, slope, remember, is vertical rise over horizontal run. So let's talk about what does this mean. And so if we have a smaller slope, which is going to give us a problem that is more horizontal, or a ski slope that's more horizontal. So it'll look more similar to that. Whereas if we have a larger slope, we're going to have a more vertical. And so it's going to look much more steep like that. All right, so let's find slope from a coordinate plane. So if we look at this picture, I want to know, what am I doing to get from A to B? Well, if I'm getting from A to B, I'm going to go down 1, 2, 3, and then I'm going to go to the right 1, 2, 3, 4, 5, 6. So I went down 3 and right 6. And in your notes, remember that slope is vertical rise over horizontal run. And if you notice here, you have seen it before as rise over run. So the slope we refer to as m of a line containing 2 points with the coordinates x1, y1 and x2, y2 can be found by this formula, where we take y2 minus y1 over x2 minus x1. So the y2 minus y1, that's going to give us this vertical rise here. And if we take x2 minus x1, that's going to give us this horizontal run. All right, so now we have some problems where we're going to find the slope of each graph. So let's go ahead and take a look at number 1. And first off, we need to label our points. So k is up 3 and over 3. And our j is down 1 and to the left 2. All right, so we're going to just plug these in. It doesn't matter which point you call x1, y1, as long as you keep the 1's together and the 2's together. So if I flip-flop those and called 3, 3, x2, y2, and negative 1, negative 2, x1, y1, we should still receive the same answer when we do our problem. All right, so let's plug into that formula. Remember, it's y2 minus y1 over x2 minus x1. So we're going to plug in our y2 is negative 2 minus our y3, or our y1, which is 3, and then negative 1 minus our 3. So if we go ahead and do that, negative 2 minus 3 gives us negative 5, and negative 1 minus 3 gives us negative 4. If we have two negatives, they cancel out, and so our slope is 5 over 4. And we leave slope as an improper fraction. All right, so for tomorrow, your job is to get number 2 done. All right, so let's look at 3 and 4. Again, I'll do one and you guys can do the other one, and I'm going to do problem 4 with you. If we look, Q is 2, 1, and R is 2, negative 4. So we're going to just label those with x1, y1 and x2, y2. Again, doesn't matter which one's which. So we're going to plug into our formula. So we're going to take 1 minus, now it's negative 4, so I do have to write that negative. And then I'm going to take 2 minus 2 on the bottom. Minus a negative changes into plus a positive. So we get 5 on the top. And on the bottom, 2 minus 2 gives us 0. Now think back, can I take a number and divide it by 0? If you try that on your calculator right now, it's going to tell you error, 0 arrow, can't divide by 0, because, again, we can't divide by 0. So if we ever do have 0 on the bottom, we call that undefined. It has an undefined slope. All right, So let's take a look at the next section. It says lines B and R are parallel. Line B passes through points 3, 6 and negative 9, 2. And line R passes through 5, 4 and 2, 3. We talked about in our 3.1, 3.2 notes all about parallel lines. So now let's look at their slope. So for our slope for B, we are going to take 2 minus 6 on the top and negative 9 minus 3. So those numbers came from x1, y1, x2, y2. All right, so if I subtract those, then I get negative 4 over negative 12. Again, remember a negative over negative, we're going to change that to plus positive, and this reduces to 1/3. All right, let's go ahead and do it for line R. Again, x1, y1, x2, y2. So 3 minus 4 and 2 minus 5. 3 minus 4 leaves me with a negative 1 on the top. 2 minus 5 leaves me with a negative 3. If I simplify those, I get a slope of 1/3. So let's take a look at that. Both of those slopes are 1/3, and that's going to come into play in the very next part of ours. So for tomorrow, I want you guys to do the slopes for the lines that are perpendicular. All right, so I have this nice little drawing here for you, and it says two lines have the same slope if and only if they are, well, we just did that, and we've noticed that those are parallel lines. Okay, two lines are perpendicular if and only if their slopes are blank. So I want you to look back at that last problem you did and fill in what those are, and we'll talk about that tomorrow. So our last problem here, if we look, is are the following lines parallel, perpendicular, or neither? So I want you to find the slope for our line R here, x1, y1, x2, y2, and then find the slope for line S, x1, y1, x2, y2. And based on those two slopes, you need to tell me, are they parallel, perpendicular, or neither? And that's where we're going to end it today. So you come back with that done for tomorrow, and we'll talk then. See you.